Hi everyone, welcome back to the channel. So let's do a problem today which is relatively difficult, but there are a lot of questions in IIT JEE Advanced and also Olympiad that come from this concept. And this is definitely going to give you tons of concepts when it comes to solving such problems. Okay, so let me explain the problem first. There is a tiny particle of mass m which is sitting at the top of the hemisphere and then it starts coming down. Every surface is frictionless, so the bigger mass m, which is the hemisphere, will also start moving in the left direction. And so we need to figure out the angle theta at which the particle will lose the contact with the hemisphere. Okay, and there is a special case. Well, let's say when hemisphere is really heavy compared to the point mass m, then what is this angle theta? Okay, so I would request you to give it a try and then come back and see the solution. Okay, let's solve the problem now. So as usual, let's draw the free body diagram first. So let's say this is the particle at certain point in time and it is making, let's say, an angle theta. Okay, and the velocity of this particle, let's say, is u, and this is going to be tangent at this point. Let's say this point is p, and let's say that the velocity of hemisphere is v in the left direction. Let's assume that this direction is x and this direction is y. Okay, now let's understand the velocities of the particle p. Okay, let's say this is p. Because there is a velocity u in this direction at point p, so there will be some horizontal component of this velocity ux, but the point mass is also going in left direction because it is still in contact with the hemisphere and which is going towards the left. And then there is a vertical component uy. Okay, if this angle is theta, then this is theta, this is 90 minus theta, and this is also theta. So then we can write ux equal to u cos theta minus v, and uy is u sin theta. Okay, tan theta is uy by ux plus v. Okay, so this should be simple enough. We are doing this because we need to know the absolute velocity u in terms of ux and ui. So we need to figure out the actual ux and ui. Since the overall force in the x direction, all external force, is 0, therefore linear momentum is conserved. Okay, it means that m times v is equal to mux, because we need to take the horizontal velocity here. The linear momentum is conserved in x direction, right? Therefore v is m by m ux and equal to, let's say, some constant eta ux, where eta is m by m. Okay, let's just define this. Then from here, tan theta becomes uy by ux plus v is eta ux, so we can write eta ux. Therefore uy is ux 1 plus tan theta. Okay, the expression for uy. Okay, the hard work is done now, because now we have a expression for ui and also we have an expression for v. Okay, what is u then? Then u is nothing but the vector sum of ux and ui. So ux square plus uy square, okay, which is nothing but ux square, if we take common, 1 plus a whole square tan square theta. Okay, so this is the u square. Okay, Now, at this point, when the particle is at point P, then we can conserve the energy. Let's say energy is conserved. Energy is going to be conserved, right? It's clear because there is no external force. So therefore, the total loss in potential energy is how much? Mg R 1 minus cos theta. This should be simple because this part is R cos theta. Therefore, the loss is mgr minus mgr cos theta. Okay. And that should be equal to half mu square plus half mv square. Right. So far, so good. Now we would like to get the equation in ux because there are two ways to solve this problem. One is by maximizing the ux at this point P where it is leaving the hemisphere, because if ux is maximum, then it should leave the hemisphere. And the second one is usual. We will balance the centripetal force and then put the normal to 0 and then see what is the velocity. So let's get the expression of ux first. Okay. So then this will become half m ux square 1 plus eta square tan square theta and plus 1 by 2 m, and v is nothing but eta ux, so eta square ux square. Okay, and then we get 1 by 2, take the m ux square outside as common, then 1 plus eta square tan square theta plus m by m eta square, and if you see m by m is nothing but 1 by eta because eta is m by m. Therefore 2gr 1 minus cos theta, we can take the 2 that side, and then m and m will cancel out. So this is ux square 1 plus eta, this is nothing but eta because m by m is 1 by eta, plus 1 by eta square tan square theta. Therefore ux square 1 plus n 1 plus eta tan square theta. Hence ux square is 2gr 1 minus cos theta divided by 1 plus eta 1 plus eta tan square theta. Okay, so far so good. This is simple enough. Okay, let's call this equation A. Now there are two ways to solve this problem, as I said earlier. Point mass will leave the hemisphere when ux is maximum. Okay, right? Because ux is the velocity in this direction. So when this is maximum, at that point in time, it will leave the hemisphere. So one way to solve this problem is differentiate the ux with respect to theta and then put that to 0 and find theta. Okay. So this is one approach which I leave it to you as an exercise. You can do it. But let's try to solve it using the usual manner where we assume that at this point in time when this is about to leave the hemisphere, then there is a normal force N which is acting. Okay, and mg is down, and then it has a velocity u. Okay, at this point in time in this direction from the frame of hemisphere, we can write mg cos theta minus n equal to mu square by r. Okay, and what is u? So if you see here, u cos theta, from here u cos theta is ux plus v, so we can write u cos theta as ux plus v, which is ux plus eta ux, which is 1 plus eta ux, and therefore the u is 1 plus eta ux by cos theta. So let's take this. So mg cos theta minus n equal to m by r 1 plus eta square cos square theta and ux square. Okay, and we can put n to 0 when it is breaking off. Hence what we get is g cos theta is equal to 1 plus square by r cos square theta, and ux square is, we've already got the expression for ux square, that is 2gr 1 minus cos theta divided by 1 plus eta 1 plus eta tan square theta. Okay, so a lot of things will cancel out. R will cancel out. 1 plus eta will cancel out here. So therefore what we get is square theta, everything in the denominator here on the left hand side. So this becomes cos q theta and 1 plus eta tan square theta, and that is equal to 2 1 plus theta 1 minus cos theta. Okay, so it's just a matter of simplifying this equation now. So we can write this cos q theta plus 1 plus eta, and we can write this sin square theta by cos square theta into cos q theta. So we can simply write sin square theta cos theta and 2 1 plus theta 1 minus cos theta. Now let's simplify it further. Cos q theta plus 1 plus eta, we can write this as 1 minus cos square theta cos theta, and then minus 2 1 plus eta 1 minus cos theta, and that is equal to 0. Okay, now let's just further simplify it. So we can take 1 plus eta as common, and then cos theta minus cos q theta, okay, minus 2 1 plus eta 1 minus cos theta equal to 0. Let's expand this. So cos theta minus cos q theta plus eta cos theta minus eta cos q theta minus plus n plus 2 1 plus eta cos theta equal to 0. Okay, so this will cancel out. Okay, so what we have is minus eta cos q theta plus 3 1 plus eta cos theta, okay, and minus 2 1 plus equal to 0. So if you see this one, this will become 1 plus eta cos theta. So this whole thing will become this and this 3 1 plus eta cos theta. Therefore eta cos q theta minus 3 1 plus eta cos theta plus 2 1 plus eta equal to 0. So this is the final expression for cos theta, and it is pretty formidable if you see to solve, because the eta is a variable here, but we can solve this problem for some special cases. So when n is, let's say, 1, that implies m is equal to m, then what we get is cos q theta minus 6 cos theta plus 4 equal to 0. And this is simple because this we can rewrite as cos theta minus 2, cos square theta plus 2 cos theta minus 2 equal to 0. This cannot be 0, so which means this is 0. And if you solve this, this will give you cos theta is root 3 minus 1. Okay. And now the question is asking if m is really greater than m, that means n with eta, which is m by m, is really less than 1. So it tends to 0. So then what we get is minus 3 cos theta plus 2 equal to 0. And that is cos theta is 2 by 3. And this is the case when you fix the hemisphere, if hemisphere is fixed. So this problem you would have solved already. Let's say if hemisphere is fixed, then you get theta as same, cos inverse 2 by 3. So this matches with our solution also. So this is the final expression for theta. Okay. And the other option that we discussed, that if you maximize ux, you will again get similar expression for the theta. So I hope you learned few things here and you enjoyed solving this problem. Thank you very much. Send me your feedback, your comments, or any question that you have. Leave a comment there or send me an email and subscribe to the channel. Thank you very much. Subscribe and gain access to concepts and tips for doing better in IIT, JEE or other examinations. Keep up the great work.